All right, you should have these notes open. Well, I'm waiting for this recording to start, so I got it started, and then I was like, oh crap, I forgot to do the recording. And then they did the Pledge of Allegiance, and so here we go. Okay, so water, so solid in which water molecules are trapped. The water molecules then become part of the crystal, and it's called water of hydration. And a hydrate then is a compound that has a specific amount of water bound to the atoms. Okay. Did I do okay, Braylon? Everything's looking good? Okay. All right. So, number of water molecules is written as part of the formula with a dot in between, and then they tell you how many waters are attached.
Oh.
So the water has to be included in the molar mass calculations, and the compounds can be found. What was I trying to say there?
Water. Compounds can be found with a
variety of water molecules. So some of them will be like monohydrate or dihydrate or hexahydrate or heptahydrate. So it just depends on what the stuff is. So this is copper sulfate here. It's always found with 5 waters. But other ones are found with other. So it just varies by what the thing is and how much water it can actually absorb. Okay? To analyze the hydrate, the water must be driven off or heated. So you heat the compound, and that's what you're going to do tomorrow, is you're going to take a sample that has that water attached to it. You're going to heat it, and then you're going to weigh it or measure the mass of it after the water's been driven off, and then you can figure out how much water was in there to begin with. Okay? So you can calculate the mass of water by subtracting the beginning mass of the crystal from the ending mass, because you're heating the water. The water is vaporizing out and going up into the air. And then you can figure out the difference between those two masses tells you how much water was in there. Okay? So these are done very similarly to our empirical formulas. Okay? So here we have magnesium sulfate and we have water. And this is actually, if you've ever heard of Epsom salt, sometimes athletes and different people, if you have like a sore muscle or that sort of thing, you'll soak in, like get a bath, or, you know, if your feet are hurting, you can do like a foot bath or something. And you can put that in there and it helps bring down the swelling. Okay. But magnesium sulfate then is 48% of the crystal, and then 51.2% water. So they want to know what the formula and the name for that is. So we're going to take this, we're going to assume that we have a 100-gram sample, and we're going to change these percents then into grams. So steps 1 and 2 are done. Then we're going to take our moles of MgSO4, or we're going to take our grams and calculate moles by dividing by the molar mass of MgSO4. What?
Correct.
Okay.
Then confirmed it for good.
So 48.8 divided by 120.4, we get 0.405 moles. Make sure you're keeping 3 sig figs in this stop. Then 51.2 grams of water. Now this one is 18, and just go ahead and memorize that guy because you're going to use him a lot for the rest of the year. So if you memorize the molar mass of water, it's going to save you a little bit of time. You don't have to. I mean, you can always calculate it, but it's going to save you time if you do.
2.84 repeating.
Okay, so 2.84. Now, with these hydrate problems, the moles of water have to be greater than or equal to the crystals moles. Because if you think about it, it's a crystal with water attached to it. Okay? So the least you could have would be 1 to 1. And in that case, these would be equal to each other. In any other case scenario, you're going to have one crystal with waters attached to it. So this number, if it comes out greater than this number, you probably did something wrong. Does that make sense? Okay. So just like with our empiricals, we're going to divide by the lowest mole value, so 0.405. And that equals 7. So our formula for this would be MgSO4. Then you do this dot, like a multiplication dot. You put the 7 from your calculation, H2O. That means that there's 7 for each one of those crystals. There's 7 waters attached to that crystal.
That's not bad.
Okay. The name of this then would be magnesium sulfate. And these prefixes are the same prefixes that we used back when we were doing not acid naming, covalent naming. Okay, so covalent naming. So this ends up being magnesium sulfate heptahydrate.
Cool.
Okay.
Is that all we're doing today?
Yep, we're just going to talk about a couple more problems here and then we're done. All right, anhydrous means without water. So a lot of times the prefix an means without. So without water, we can use things called drying agents. And for example, if you get clothes or shoes or stuff like that, a lot of times you'll see these little packets. Have you seen these in, like, and it says do not eat, you know?
Yeah.
They're in there so that when the product is getting shipped, it doesn't soak up moisture, because if it soaks up moisture, it might end up molding and then the product's ruined by the time it gets to you.
It doesn't actually touch all of the product? How does it work?
No, it just kind of sucks the moisture out of the air or out of the product. And you've seen these like in your shoes and coat pockets and different things like that. Because, I mean, think about it. They're shipping this stuff from China, right? It's coming in these big, huge cargo ships. It's coming across the ocean to get here. Very different climate changes between all of those different regions to get to Wisconsin, okay? And so because of that, they're trying to protect the product from moisture, because if there's any kind of mold spores on that product, which there's mold spores everywhere, let's face it, okay, and that product gets moist, chances are it's going to mold. And so then they've lost their product. They've manufactured it, they shipped it all the way over here, and it's no good. Okay.
What are those packets like directly in water?
No.
It like swells up. The other thing that you'll see this in is baby diapers. Okay, baby diapers, between the layers of the thing that touches the baby and the outside, they have a powder in there, and that powder will soak up water. Yeah.
What happens if you eat the little, like, do not eat shoe packets and you don't?
I don't know.
They're probably like dehydrated.
It's silica gel, so it's like eating, this is like eating sand, you know? So I don't know that it would necessarily hurt you, but it's not going to be beneficial. So baby diapers are another example. So the baby pees on the thing, and then the diaper, I don't know if you guys have ever had to like change baby diapers or not, but they kind of swell up, okay? And they feel kind of like gel almost inside. That is an example of one of these desiccants. Any place that has a lot of moisture, like in Florida, we can oftentimes down there at our house down there, we'll keep in our different parts of the house, we'll keep these damp rid things. And it essentially takes the moisture out of the air and makes it less humid. So, anyway, so, all right. So determine the mass percent of anhydrous sodium carbonate in water in sodium carbonate Deca hydrate. So Deca means what? 10, right? So they want to know mass percent of the anhydrous form. So we've got to figure out the formula for this, which is Na2CO3. This is Deca hydrate. So we need to figure out the molar mass for this guy, and we need to figure out the molar mass for the whole thing. So sodium is 23 each, so that'd be 46, and a carbon is 12. And 3 oxygens are 48. I got 106. Okay. And then for the water part of that, I got 180, because 10 times 18, and I didn't write 180, I wrote 188. There we go. 10 times 18 is 180. Okay, so they want to know the mass percent of this stuff. So that's going to be 106. That's my part divided by the whole. And I goofed that again. It's going to be a 6 and an 8 and a 286. Cool. Times 100. So 106 divided by 286. So that's 37.1%. And that's Na2CO3.
And then we do the same for the water?
I need that one more time.
Then we do the same for the water?
Well, they determine the mass percent. Yeah, they wanted it in water too. So 180 divided by 286 times 100. Or the other thing, since you only have 2 components here, what could you do? Yeah. So that would be 62.9. Either way, you should end up with the same answer. Okay? Make sense?
Yes.
That is chapter 10.
Wait, that's it?
That's chapter 10.
Oh. Okay.
So we start chapter 11 tomorrow.
We don't have a, oh, wait, no.
I'm doing a combined test between the two. Okay, so tonight for homework you have 10.5, which is your last assignment for chapter 10. You also have a lab from yesterday that you can be working on. If you have questions on that, certainly bring that up. You might want